Good afternoon to dear children. Welcome to Sanvi Learning Services. This is your physical science class. Right. In the last class, we discussed chemical equations. Right. That is the second chapter. So in the last class, we completely discussed about balancing of chemical equation. Yes. So in this session, I want to start next chapter, acids, bases, and salts. Yes. Wait a minute, I'll share the screen here. Yes. So here our next chapter, acids, bases, and salts. So first of all, I want to explain in this chapter. Right, I'll explain all the keywords which are given in this chapter. So look at here. The first one, indicators. Right. So here, indicators nothing but the substances or solutions used to indicate the nature of a solution for acidity or basicity, or called indicators. So here, generally we hear this indicator word while driving. We are driving in a bike or a vehicle, any vehicle, right? So there, if you want to turn right or left, there will use indicators, right? So that indicator is to indicate to our backside people. We are going to right side or we are going to left side, right? So there we are use indicators. There, right? So there we use indicators. So here in this, why we are using indicators in the chemistry means to indicate acidity or basicity of the solution, whether the solution is acid or base, right? So here the substances are solutions used to indicate the nature of a solution for acidity or basicity, or called indicators. So here we have some examples for indicators: litmus paper and universal indicators, methyl orange, phenolphthalein. Okay, so all these are indicators here. So this is the definition of indicators. Next one, acid. So here, acids are source to taste and turn blue litmus to red, right? So here, acids are sour to taste and turn blue litmus to red. So here some examples are given for acids: HCl and H2SO4, right? These are concentrated acids here, and lemon water, tamarind juice, vinegar, all these are also acids. Now here come to base. So bases are soapy to touch and turn red litmus to blue. Okay, so here examples for bases: sodium hydroxide, NaOH, magnesium hydroxide, MgOH taken to toothpaste, soap water, etc. So all these are comes under bases. So we'll discuss more about acids and bases in this chapter briefly. Okay, so just I'm giving just definitions here. So next one, red litmus. So here this litmus paper is an indicator to indicate the solution is whether acid or base, right? So here we have two types of litmus papers. One is a red litmus paper and one is a blue litmus paper. So here look at the red litmus paper. So it is an indicator. Okay, red litmus paper is an indicator which turns to blue color in basic medium. Here, if the red color litmus paper turns to blue, then the solution is having basic nature, or we can say the solution is base. Okay, next, blue litmus. So here blue litmus is also an indicator, so which turns to red in acidic medium. Okay, blue litmus paper turns here to red in acid solutions. Okay, so you can observe here figure, red litmus paper with a drop of base here and blue litmus paper with a drop of acid here. So here this red litmus paper is changed into blue, right? So here we can say that the solution is base. So when we drop one of the base solution here on the red litmus paper, the red litmus paper changed into blue, right? And similarly here, blue color litmus paper is changed into red color. So when we drop one acid on this paper, blue color litmus paper, so the blue color litmus paper changed into red color. That indicates that the solution is an acid solution. And next one, phenolphthalein indicator. Okay, so here, this phenolphthalein indicator, so it is a colorless solution. Okay, so here, this phenolphthalein is a colorless solution. It is used as an indicator. It does not change its color in acidic medium and turns pink color in basic medium. So here, this phenolphthalein is used to indicate acid solutions and base solutions, right? So when we add this phenolphthalein indicator to an acid solution, so here, this phenolphthalein solution will not show any color in acid solution. Okay, the color of the solution is remains same. And when we add this phenolphthalein indicator to base solution, the solution is changed into pink color. Okay, so that pink color indicates that the solution is base. Okay, so this phenolphthalein indicator in acid solution, it is colorless, and in base solution, it is pink color. Okay, next. So, wait a minute. Sir, can you hear me? Excuse me, sir. Hello, excuse me, sir.
Ma'am.
Sir, the sign not changing here, sir. It is not showing any pen to write here. So it is showing only pen to write here.
To rub, there is no option.
No, sir.
Okay, continue. I'll check out. I have checked out already.
So once remove me from this Zoom meeting. I want to rejoin again. I can't press anything here. So please remove me from Zoom meeting.
If I remove, you may not be able to join, I think, ma'am. Are you able to leave, ma'am?
No, sir.
Okay, I'll remove, ma'am. Just you will have to join with a slight name change.
Okay, okay, sir.
Then only you will be able, I think.
Okay, sir.
Okay, students, please wait. There is some technical problem. It will be resolved soon. Dear students, I hope that you have all started writing your classworks. Please don't neglect. Your subject teachers might have informed you about the procedure. Within a couple of days, every subject teacher is going to inform you, enlighten you with the procedure of writing the CW. If you haven't started, we'll be giving you the procedure.
Yes, okay. Sorry for the disturbance. Right, I'll continue here. Wait a minute, I'll share the screen. Yes. So look at here, the next one, methyl orange. So here methyl orange is also an indicator. Okay. So here it is an orange colored indicator. Okay. It is an orange colored indicator. It changes to red in acidic medium and turns to yellow in basic medium. Okay. So actually the color of methyl orange is orange color here. So when we add this methyl orange to acid solution, the solution is changed to red color. Okay, so the red color indicates that the solution is acid. And next, if we add this methyl orange solution to base, so there the solution is changed into yellow in color. Okay, so that yellow color indicates the solution is in basic medium. Okay, so this is methyl orange. And next one, salts. So here, a substance which is formed as a result of the neutralization reaction between an acid and a base. That means here, when an acid reacts with base, it will form salt and water. So this reaction is known as neutralization reaction. That means the solution, okay, in a beaker if you have taken an acid and base, so what is the nature of solution here means? So here the solution is not having acid nature or base nature. Here the acid and base both are neutralized. So it will form salt and water. So we can say that a substance which is formed as a result of the neutralization reaction between an acid and a base. So always when an acid reacts with base, it will form salt and water. Okay, right. So the next one, neutralization. So here the reaction of an acid with a base to give a salt and water is known as a neutralization. Just now I explained that, right? Or salt is obtained when an acid reacts with a base is known as neutralization reaction. Okay, so here neutralization reaction means the reaction of an acid with a base to give salt and water, right, is known as neutralization. Or also we can say that salt is obtained when an acid reacts with a base. Okay, so that is also neutralization reaction, right? So the next one, guard tube. So this is a drying tube used in experiments. Okay, so this guard tube is used in experiments, right? So it is one of the drying tube. And next one, hydronium ion. Hydronium ion means hydrogen ion cannot exist as base ions. Okay, hydrogen ion cannot exist as base ions. So they associate with water molecules and exist as hydrated ions with here each H plus attached by 4 to 6 water molecules. Okay, so here the hydronium ion is represented by H3O plus. Hydronium ion means H3O plus. So here this hydrogen, right, this water molecules, and here this hydrated ion, that means it is combined with, it is attached to 4 to 6 water molecules here. Okay, so here this H plus is attached to 4 to 6 water molecules. Then it will form the hydronium ion. So hydronium ion is a H3O plus, is known as hydronium ion. And next one, alkalis. So alkalis are also known as bases. Okay, so bases which are soluble in water are called alkalis. Okay, bases which are soluble in water are called alkalis. And next, strong acid. So an acid which has more H3O plus ions is called strong acid. Okay, in an acid it will contain H plus ions. Okay, so in that it will compulsory contains H plus ions. So here an acid which has more H3O plus ions is called strong acid. So here HCl, best example is a HCl, hydrochloric acid. So it is one of the strongest acid. So here some more examples are given. Strong acids HNO3, HCl, HBr, HI, H2SO4 and HClO4 or strong acids, right? So here you can observe the chemical equation here. HCl is combines with water, gives, that means releases H3O plus ions, right? So in a beaker, if you are taken some water, right, if you are adding HCl to this solution, So here this HCl and H2O will combine together, and in that solution the H3O plus ions releases more. Okay, so releasing of H3O plus ions more in that solution. So we can say that the HCl is one of the strong acid. So remember that acids releases H3O plus ions more in the solution. Okay, right. Now strong base. So a base which has more OH minus ions is called strong base. So in acid, if more H3O plus ions will present means we can say that is a strongest acid, right? So in base, the solution which has more OH minus ions is called strong base. So here the best example given sodium hydroxide, NaOH. It is one of the strong base here. Okay, right. Now next one, universal indicator. So here universal indicator is a mixture of several indicators. Okay, so universal indicator means it is a mixture of several indicators. So it shows different colors of different concentration of hydrogen ions in a solution. Okay, so on pH scale it will show different colors of different concentration of hydrogens in a solution. And next one, pH scale. So here this scale is used for measuring hydrogen ion concentration in a solution. Okay, so here a scale for measuring hydrogen ion concentration in a solution is called pH scale. You can see here, this is a pH scale here. Here we have 0 to 14 in this scale. So here 7 is the neutral. Okay, 7 is a neutral and 1 to 6 are acidic nature and 8 to 14 are bases or alkaline also we can say. Okay, so here this scale is used for hydrogen ion concentration in a solution. So we'll learn more about pH scale in further classes. So here next one, potence, that means power. Okay, potence is nothing but power. Next one, antacids. So a base used to get rid of pain and irritation caused in stomach due to indigestion of food. Sometimes we feel indigestion of food like pain and irritation, right? That is due to releasing of excess of acid in our stomach, right? So in our stomach, one acid will release this, right? That is a HCl acid. In our stomach, HCl acid releases to digestion of food. It will help in digestion of food in our stomach. So if the acid, this HCl acid releases more in our stomach means at that time we feel pain and irritation, right? So we feel that indigestion of food. So at that time we have to take base to that acid to neutralize that acid, right? So that is a antacid, right? You know that some people will take eno, right? So that is to decrease the acidic nature in the stomach, right? Yes. Now, tooth decay. So here, corrosion of tooth due to the degradation of sugar and food particles remaining in the mouth. Okay, so why the corrosion of tooth takes place means after taking of food, if we'll not wash our mouth properly, so there the food particles will remains in the mouth. Okay, like a sugar particles. That means in a food, glucose will present, no. So and if we'll take any food item, it will, if it will remains in the mouth means at the time corrosion of tooth will takes place. That we call as a tooth decay. So that's why we have to wash our mouth properly after taking any food. So corrosion of tooth due to the degradation of sugar and food particles remaining in the mouth. So next one, family of salts. So that means salts having the same positive or negative radicals belong to a family called a family of salts. Okay, so here if all salts having same number of positive ions and same number of negative ions means they all belongs to one family. So we call that salts as a family of salts. Okay, there the number of positive ions and negative ions are equal. And next, common salt or table salt. So we know we'll use common salt or table salt in our home, right? So here that is a sodium chloride. The formula of sodium chloride is NaCl. Okay, so this NaCl is a common salt or table salt. Next one, bleaching powder. So here this bleaching powder is formed by the action of chlorine on dry slaked lime. Okay, so here it will form on the reaction between dry slaked lime and chlorine. Then the formation of bleaching powder takes place. Okay, we'll discuss it about it later. Now, baking soda. So sodium bicarbonate salt is used in kitchen for making tasty and crispy pakoras. Okay, so we can also call baking soda as a sodium bicarbonate. Okay, NaHCO3. This is the sodium bicarbonate. So here this salt is used in kitchen for making tasty and crispy items. Okay, we'll use this mostly in pakoras, right? We can also call it as a baking soda. And next, washing soda. So this is the sodium carbonate, Na2CO3, right? So here this washing soda, also called as a sodium carbonate salt, is used in washing clothes. Okay, so it is used in washing clothes and etc. So here next one, hydrated salt. Okay, so salt which contains water. Okay, so hydrated salt, salt which contains water. Next, water of crystallization. So water of crystallization is a fixed number of water molecules present in one formula unit of salt. Okay, if you have taken any salt, so in that the fixed number of water molecules will be present. That is known as water of crystallization. Okay, fixed number of water molecules present in one formula unit of a salt. Okay, the next one, plaster of Paris. So here, this you know about POP, plaster of Paris, nothing but we can also know it as a POP. So on careful heating of gypsum. Okay, this is the formula of gypsum here, CaSO4 dot 2H2O. So on careful heating of gypsum at 373 Kelvin, okay, when we are heating this gypsum at 373 Kelvin, it loses water molecules partially, not completely here. Just partially, the gypsum loses water molecules to become calcium sulfate hemihydrate. Okay, so now it is hemihydrate because here it loses water molecules partially. Before we have CaSO4 dot 2H2O. Now we have CaSO4 dot half H2O. Okay, which is called plaster of Paris. So the formula of plaster of Paris, CaSO4 dot half H2O. Okay. So here given that chemical name calcium sulfate, that is gypsum. So chemical formula CaSO4 dot 2H2O. So the reaction you can observe here. CaSO4 dot 2H2O gives here CaSO4 dot 0.5 H2O plus 1.5 H2O. So from this here it loses just partially water molecules here. So it becomes CaSO4 dot half H2O, that is a POP or plaster of Paris. And next one, litmus solution. So here a natural indicator extracted from certain lichens. Okay, so here a natural indicator extracted from certain lichens is known as litmus solution. So lichen means this is a rock moss. Okay, so we'll discuss about this later clearly. So next one, endothermic reaction. So endothermic reaction nothing but a chemical reaction in which heat is absorbed. Okay, in any chemical reaction, if heat is absorbed, we can say that that is a endothermic reaction. And in any chemical reaction, if heat is released, then we can say that that is exothermic reaction. Okay, heat absorbed means that is endothermic reaction, and heat released means that is exothermic reaction. And next one, aqueous solution. So aqueous solution nothing but the solution in which the solvent is water. We know one solution contains solute and solvent. Okay, solution equals to solute plus solvent. So in solution, the solute part is less and solvent part is more. Okay, we'll take a solute part in less amount and solvent part in more amount. Okay, so aqueous solution means the solution in which the solvent is water. Okay, next one, concentration of a solution. So the amount of solute present per unit volume or per unit mass of the solution. Okay, concentration of solution means the amount of solute present per unit volume or per unit mass of the solution. So we decide the concentration of the solution based on the amount of solute. Okay, based on the amount of solute only, we'll decide the concentration of the solution. Next one, saturated solution. So saturated solution nothing but the solution in which amount of solute is equal to the solubility. Okay, so here this is also depends upon the solute particles only. So here in solution, okay, the solution in which amount of solute is equal to the solubility here. And unsaturated solution means the solution in which solute is less than the solvent. Okay, so in unsaturated solution, the solute is less than the solvent. And next one, supersaturated solution. So supersaturated solution means the solution in which the solute dissolved is more than its solubility. Okay, so here the solute is completely dissolved, okay, more than its solubility. Then we can say that that is a supersaturated solution. And next one, dry slaked lime. So dry slaked lime is nothing but here CaOH taken 2, calcium hydroxide is a dry slaked lime. And next, brine solution. So this is an aqueous solution of common salt. Okay, an aqueous solution of common salt we are saying here. So an aqueous solution of common salt means in that solvent is the water. Okay, in that solution, solvent is a water and salt is a solute there. And next, anode. Anode means a positive electrode. Cathode means negative electrode. Okay, anode is a positive electrode, cathode negative electrode. Okay, so we will discuss the remaining topic in the next class. Okay, thank you children, thank you all of you.
Okay, dear students, as your biology teacher is not feeling well today, I'll be sharing the previous class. Please have a revision of that, okay?
Slide share you want. Good afternoon, one and all. Welcome to Shanvi Learning Services. Welcome to biology class. Lesson number 2, respiration. Be attentive, all of you. See here, we are in the topic of gases exchange. Okay, so gases exchange takes place within the lungs by diffusion. Okay, gases exchange takes place within the lungs by diffusion from the alveoli to blood capillaries. So as we know, gases exchange takes place at the lungs level. Okay, gas exchange takes place at the lungs level. So here, gas exchange takes place within the lungs by diffusion process. So what is the diffusion, sir? What is the diffusion? So simply here, diffusion is a movement of air. Okay, diffusion is a movement of air from an area of high concentration to an area of low concentration. Okay, so gases exchange takes place within the lungs by diffusion from the alveoli to blood capillaries. So alveoli is a plural. Like alveoli is a air sac like complex structures which are present in the lungs. Okay, so here the gas exchanging taking place within the lungs by diffusion process from the alveoli which is present in the lungs to blood capillaries. Okay, in blood capillaries, blood will flow. Next, see here, look at the screen, all of you. Lungs in the vertebrates. Lungs in the vertebrates. So what are the vertebrates? Which will have the vertebral column. So we also comes under vertebrates because we will have backbone, vertebral column. So lungs in the vertebrates are made of several thousands of small chambers called alveoli. Alveolus is a singular, alveoli is a plural. So lungs in the vertebrates are made of several thousands of small chambers. Several thousands of small chambers are present in the lungs. That small chambers, air sacs, are called alveoli. Alveoli. Next, lungs in the vertebrates, as we have discussed just now, are made up of several thousands of small chambers called alveoli. Here, look at the screen. Left side, alveolus are given clearly. Alveoli is given clearly. Now, see here, alveoli is the structural and functional unit of the lung. Okay, alveoli is the structural and functional unit of the lung. Look at the screen how alveoli and how the blood capillaries are there. Now, here each alveolus, singular, each alveolus is supplied with a branch of bronchiole. The branch of bronchiole and with capillaries, with blood capillaries, which brings the deoxygenated blood. Okay, each alveolus is supplied with a branch of the bronchiole and with capillaries, which bring the deoxygenated blood. See here, when exchange of gases happens at the lungs level, the blood cells are carrying the oxygen to the cell, like tissue level. Their cellular respiration is taking place. Then in the cellular respiration, three things are releasing. One is carbon dioxide, one more energy, and one other one water. That carbon dioxide again bring back to the lungs level by the blood, which will float in the blood capillaries. As you know, when it's bring back to the lungs, then from blood capillaries by the diffusion process, carbon dioxide will move from the blood capillaries to the alveoli of lungs, and from the alveoli of lungs to the blood capillaries oxygen. So like that, oxygen to the blood capillaries and carbon dioxide to the lungs, like that exchange, gases exchange is taking place. Gases exchange is taking place. Okay, children. Next one. Each alveolus. Each alveolus is supplied with a branch of bronchiole and with capillaries, as we discussed just now, which brings the deoxygenated blood. See here, blood dark comma red in color. Blood dark comma red in color flows from the heart. Flows from the heart through these capillaries. Through these capillaries and collect oxygen from the alveoli. Okay, now look at the screen, all of you. Blood dark comma red in color flows from where? From the heart. Okay, blood dark comma red in color flows from the heart through these capillaries. Through these capillaries, and that can collect oxygen from the alveoli. Oxygen from the alveoli. Look at the screen. Air in and out. So oxygen in, carbon dioxide out. It is clearly shown with arrow mark, light blue, thick blue. Oxygen in, light blue, and thick blue of carbon dioxide out. So this exchange of gases. And red blood cells in capillaries. See, blood also tissue consists a number of cells. So red blood cells in capillaries, floating in the capillaries, and alveoli, that particular dome shape like alveoli, and oxygenated blood out. Oxygenated blood is out. Like blood is carrying that oxygenated blood. Blood is carrying that oxygen. So which blood is consists the oxygen, that is oxygenated blood. It will reach this tissue. Okay, then when tissue, there is a particular blood cells reach the tissue, this oxygen is utilized by the cells for the cellular respiration. As I have told just now, it involving the respiration process and release the energy and produce water and carbon dioxide. Then carbon dioxide again bring back to the lungs level. Like this process is going on. Okay. See here, blood dark comma red in color flows from the heart through these capillaries and collect oxygen from the alveoli. At the same time, carbon dioxide passes out of the capillaries. Carbon dioxide passes out of the capillaries. Okay, out of the capillaries. To where? To the lungs. To the lungs. And into the alveoli. When we breathe out, we get rid of this carbon dioxide. At the same time, carbon dioxide passes out of the capillaries. Carbon dioxide passes out of the blood capillaries and into the alveoli. Alveoli, where alveoli is present? In lung. In lung. So at the same time, carbon dioxide passes out of the capillaries and into the alveoli of lungs. Okay. So when we breathe out, we get rid of this carbon dioxide. Carbon dioxide can be removed from the exhale. When we breathe out, we get rid of this carbon dioxide. Okay. Next, the bright red oxygen-rich blood. The bright red oxygen-rich blood is returned to the heart. The bright red oxygen-rich blood is returned to the heart and pumped out to the body. So, which blood is like reaching the heart? The bright red oxygen-rich blood is returned to the heart. After from that heart, it is pumping to all the body parts. It is pumping to the, from heart it is pumping all body parts. Okay. Then that oxygen blood is reaching to the tissue level. There this oxygen can be utilized for the cellular respiration. As usual, it is releasing the energy and producing the water and carbon dioxide. Okay, that there is no need of carbon dioxide in that place. So that carbon dioxide will be bring back with help of that blood to the lungs. Then at the lungs level again it will be like exchange will takes place. Carbon dioxide to the lungs and oxygen to the capillaries. Like that exchange will takes place. Okay. Now see here. The bright red oxygen rich blood is returned to the heart. It is shown on the screen. Please look at screen. Look at the screen. Love you. The bright red oxygen or rich blood is returned to the heart and pumped out to the body. Pumped out to the body. Okay. Here, oxygen is given, carbon dioxide is given, blue color like light carbon dioxide and the red color oxygen shown in the figure. Next, as a result of a gas exchange, the composition of inhaled and exhaled air is different. So what is the composition, sir? Here you need to know about the composition. For example, your mother prepared a cup of tea, right? So what things are to be added in that? Like 1 cup of milk or 1 tea glass of milk or half glass of milk and half glass of water and 1 tablespoon of sugar and 1 tablespoon of tea powder. So these all are composition of that particular cup of tea or 2 cups of tea. Okay, and what percentage is? Okay, that is a composition. Here, as a result, gases exchange. The composition of inhaled and exhaled air is different. See, in inhaled air, oxygen is present, carbon dioxide is present, and nitrogen also present. What about in exhaled air? Likewise, carbon dioxide is present, oxygen is present, and nitrogen also present. Don't think we are exhaling pure carbon dioxide and don't think we are inhaling pure oxygen. Okay, so I will show now the percentage of particular components in our inhaled air and in our exhaled air also. Fine, did you get that? What is the composition? As a result of gas exchange, the composition of inhaled and exhaled air is different. The percentage of nitrogen, oxygen, carbon dioxide is different in between inhaled and exhaled air. Okay, but here nitrogen we can expect same in inhaled air 78% and in exhaled air 78%, but there is a change in between oxygen and carbon dioxide. Nitrogen will be same, then rest of the oxygen and carbon dioxide will be different in that composition of inhaled air and exhaled air. Okay, so with respect to the carbon dioxide and oxygen, here statement is given. The result of gas exchange, the composition of inhaled and exhaled air is different. Let us go for that. What is the composition of inhaled air and exhaled air? What is the percentage of nitrogen, carbon dioxide and oxygen? And in inhaled air and likewise in exhaled air also, what is the composition of oxygen, nitrogen and carbon dioxide, CO2. Okay. Let us observe the given table to get the composition of inhaled and exhaled air, percentage in inhaled air and percentage in exhaled air. What gases are present in that inhaled and exhaled air? Oxygen O2, carbon dioxide CO2 and nitrogen N2. Okay, so here oxygen is present, carbon dioxide is present and nitrogen is present. So likewise, 3 gases are present in that inhaled air and exhaled air. Then whatever the percentage in inhaled air and percentage in exhaled air. See here, oxygen percentage in inhaled air 21%. 21%. Okay, and oxygen 21% in inhaled air. What about carbon dioxide? 0.04%. 0.04%. And nitrogen 79%. In old books, the carbon dioxide given 0.03% and nitrogen 78%. Okay, please consider that. Here, oxygen 21%, carbon dioxide 0.04%, and nitrogen 79%. Okay, and what about in percentage of in exhaled air? What are the percentages of gases? Oxygen 16%, carbon. So oxygen percentage of inhaled air 21. What about exhaled air? 16. Carbon dioxide percentage of in inhaled air 0.04%. Percentage in exhaled air 4%. What about nitrogen? 79% in inhaled air and in exhaled air 79% as it is. So it means what we are inhaling in that air, oxygen, carbon dioxide, nitrogen is present, and we are taking what amount of air we are taking in inhalation, that if you consider as 100%, from that 21% of oxygen is present, 0.04% is carbon dioxide, 79% of nitrogen. Did you get me? Likewise, what amount of air you are breathing out, that is exhale air, this particular oxygen is present, carbon dioxide is present, nitrogen is present. What are the percentages of the gases are breathing out in your exhaled air? Oxygen 16%, carbon dioxide 4%, and nitrogen 79%. Okay, children? And next one, next heading is transportation of gases. Transportation of gases. Let us go to know the transportation of gases. Now, look at the picture, all of you. The relative amount of gases, and their combining capacity with hemoglobin. The relative amount of gases and their combining capacity with hemoglobin Hb. And other substances in blood determine their transport via blood in the body. Okay, now got it? The relative amount of gases and their combining capacity with who? With the hemoglobin Hb and other substances in blood determine their transport via blood in the body. Blood in the body. See here. Look at the screen that here. Relative amount of gases and their combining capacity with hemoglobin and other substances in blood determine their transport via blood in the body. Now here, when oxygen present in the air, is within normal limits, then almost half it is coiled in the body by binding to hemoglobin. When oxygen O2 present in the air is within normal limits. Okay, when O2 oxygen present in the air is within normal limits, then almost half it is coiled in the body by binding to hemoglobin. Hb plus O2. Okay. See, a protein present in the red blood cells. A protein material present in the red blood cells as oxygen is diffused from the alveoli of lung to the blood capillaries. As you know, in the blood capillaries, blood cells are like floating. Blood cells are floating is taking place. So when oxygen diffusing from the alveoli of lung to the blood capillaries, okay, a protein present in the blood cells as oxygen is diffused in the blood from alveoli of lungs. It rapidly combined with the hemoglobin to form oxyhemoglobin. Okay. So why it is combining a protein material? A protein is present in the red blood cells. Red blood cells. Was oxygen diffused from the alveoli of lungs to the blood, just present in the blood capillaries. It rapidly combined. It rapidly combined with the hemoglobin to form oxyhemoglobin. Hb is a hemoglobin, O2 is oxygen. Hb plus O2 gives rise to HbO2. Oxyhemoglobin. Oxyhemoglobin. When it is diffused into the blood, what? Oxygen. When oxygen diffused into the blood, rapidly combined with hemoglobin, because in red blood cells, the pigment is present, that is hemoglobin. So this particular oxygen, when enters into the blood, rapidly it will combine with the hemoglobin. Oxygen combined with the hemoglobin to form oxyhemoglobin. Okay. Don't read that hemoglobin oxygen. That is a oxyhemoglobin. Hb plus O2, HbO2, oxyhemoglobin. Okay. See, oxyhemoglobin. Look at the screen. Hemoglobin plus oxygen. Oxyhemoglobin. Not only can hemoglobin combine with oxygen, children, but the reverse can also happen to yield a molecule of hemoglobin and oxygen. Okay. Not only hemoglobin combined with the oxygen, but the reverse can also happen. But the reverse can also happen to yield a molecule of hemoglobin and oxygen. Yield a molecule of hemoglobin and oxygen. See, look at the screen. A beautiful picture on the screen. CO2 is usually transported as bicarbonate. SCO3. CO2 is usually transported as a bicarbonate. While some amount of it combined with hemoglobin, and rest is dissolved in the blood plasma. Rest is dissolved in blood plasma. Okay. CO2 is usually transported as bicarbonate. HCO3. CO2 is usually transported as a bicarbonate, while some amount of it combined with hemoglobin, and rest of that is dissolved in blood plasma. Okay. See here clearly shown on the figure. Look at the screen. Clearly shown in the figure. Please look at the screen. How that amount of particular carbon dioxide combined with hemoglobin and rest of dissolved in blood plasma. See here, right side in circular. It is showing like how it is dissolved in blood plasma. Okay. Then next, look at the screen, all of you. As I have told you just now, rapidly when oxygen diffuses from alveoli of lungs to the blood capillaries, nothing but to the blood, then hemoglobin rapidly combined with oxygen, right? Oxygen combined with rapidly combined with hemoglobin, Hb plus O2, HbO2. Hb plus O2 gives rise HbO2, oxyhemoglobin. As this, reverse can also happen, as I told just now. Reversible reaction also can be happen. Oxyhemoglobin can divide like hemoglobin and oxygen. If it is not happens, how the oxygen is supplied to the cell when the blood cells reaches the tissue at a cell level, like that cells to involve in the respiration process required oxygen, some amount of oxygen, right? That oxygen can be taken from the oxyhemoglobin. So at that time, oxyhemoglobin HbO2 can be divided as Hb plus O2. This O2 can be utilized for the cell to involve in the respiration process. That is cellular respiration to release the energy. So what is the use of respiration? Cellular respiration will release the energy. Okay, that's why here hemoglobin plus oxygen, it gives rise to oxyhemoglobin HbO2. As this, it can be done in reversely also, like HbO2 gives rise to Hb plus O2. Okay. Now, here gases exchange capillaries to cells and back. Gases exchange capillaries to cells and back. This topic we can discuss in next session. Let us go for feedback. Let us recall what we have learned today. If you please stay online. See, as we have discussed how exchange of gases is taking place in between alveoli and blood capillaries. What are the alveolis? Alveolis are structure and functional unit of the lungs. Okay, and how the oxygen is and oxygen and carbon dioxide exchanging at the lungs level. We have learned, and the bright red oxygen rich blood is returned to the heart and pumped out of the body. Oxygen rich blood can be pumped out to the body from the heart. Okay, after filling that oxygen, blood can be carried out to the heart. From heart, it will be pumped out over all the body parts. Okay, and here the bright red oxygen rich blood is returned to the heart and pumped out to the out of the body. As a result, the gas exchange and the composition of inhaled and exhaled is different. So we have here one table, the percentage of inhaled air and the percentage of exhaled air, and what is the composition also you know that now. The percentage of components present in the particular inhaled air and exhaled air. Exhaled air, here oxygen is present, carbon dioxide is present, and nitrogen is present. And what are the percentage of oxygen, carbon dioxide, nitrogen in the percentage of inhaled air, and whatever in percentage of the exhaled air? We have learned that. Next, transportation of gases. The amount of gases and their combining capacity with hemoglobin and other substances in blood determine the transport via blood in the body. Okay, and the oxygen how like present in the air is within normal limits. Then almost of it cold is the body by binding to hemoglobin. As we discussed how the hemoglobin is binding to the oxygen. Okay, how the air is like oxygen is diffusing from the alveoli to blood, and when oxygen diffused from the alveoli of lungs to the blood capillary, rapidly it will combine with the like the oxygen rapidly combined with the hemoglobin. So here we have a clear reactions like hemoglobin reacts with oxygen, forms oxyhemoglobin HbO2. So reverse also can be happen. HbO2 can divide like Hb plus O2. And here CO2 is usually transported as bicarbonate HCO3 bicarbonate, while some amount of it combined with hemoglobin and rest of the dissolved in the blood plasma. Here clearly given in that circular. Okay. So this is our topic and what we have learned today. Okay. In next session, let us meet with beautiful slides on topic of gaseous exchange capillaries to cells and back. Okay. Thank you. Thank
Okay, dear students, that's enough for today. Please complete your pending classworks as it is a whole